So in this video, I'd like to go over independent variables when you take partial derivatives. So I want to make sure you understand this concept so that we don't make mistakes in calculations. So in this example, right, I'll assume that we have a function f, which is a function of three variables. I'm going to write it as x, y squared, z cubed. So here's the function of three variables. So we're saying that f is a function of three variables. Now, first case, right, I'm going to take the partial of f with respect to x, and I'm going to use y comma z. And in this notation, right, that you see heavily in, especially in statistical thermodynamics, you're saying that x, y, and z are independent of each other. So the independent variables are x, y, and z. So in this case, right, changing x does not affect y and z. So we're saying this is the independent variables. Oops. That didn't turn out too well. Hold on a sec. So the three variables are independent of each other. So make sure you understand what that means. That means that changing x does not affect y and z. And in essence, you're treating y and z to be constant. So in this case, we're treating y squared and z cubed, right, to be constant. So the net effect is just y squared z cubed. So we're taking the derivative with respect to x. So the derivative of x is 1. So here's 1 times y squared z cubed, because this is constant. But be careful, because if I write this notation of saying that partial of f with respect to y, I'm assuming the independent variables are x and y are independent. So changing x does not affect y. But how come? There's a z. So if these are the independent variables, we're implicitly saying that z is a function of x and y. So in this case, we're going to take the partial of x with respect to y of x, y squared, z cubed. But if you look carefully, right, the y squared is a constant, so we can pull it out. So we're now left with y squared, because y squared is not affected by x because they're independent of each other. And so now we can calculate the partial of x with respect to y of x z cubed. And I'll continue over here. So remember, z is a function of both x's and y because x and y are independent of each other. Because of this, right, we can write this in terms of a product rule. And the product rule, basically, I'll do the long way of explaining this to make sure everybody's understanding this. I'll put a parentheses. Oops, maybe I should have done that. Let's put a braces followed by a parentheses of partial of x, parentheses of y of x, z cubed. So this is our product rule. So here is x, here's a square bracket, here is parentheses x, holding y constant, or y is the independent variable, acting on z cubed, square bracket, and the closing braces. So being very explicit about this. So here is y squared. What is the partial of x with respect to x? Well, it's just the derivative, the total derivative of x with respect to x, which is 1. So 1 times z cubed plus, here's x. Now we're taking with respect to z cubed. Doesn't look like it. But this is the chain rule. We can use the chain rule to say that this is really x times 3z squared. And then we have to leave the partial of x with respect to the partial of z with respect to the derivative of z with respect to x holding y constant. And close parentheses. So let's close braces. Notice that this is y squared z cubed. And if you expand this a little bit further, right, you get y squared z cubed plus, so I'll move 3x y squared z squared partial of z with respect to x holding y constant. Notice that this term happens to be the same. on these two terms. But the main point is that there's an extra term, and we can't even reduce this because somebody has to tell us what the function is that z. Z is a function of x and y, that's what we're told, but we don't know what that function is yet unless somebody told us that. But so this is but the main thing you have to understand is that this is not equal to the partial of f with respect to x while holding y constant. These are the two independent variables, while there are three independent variables over here. Two independent variables and three on the other side.